Unit 3 Review, Problem 1. 25 different automobiles were tested in dry conditions at a speed of 65 miles per hour for total stopping distance. The sample results, measured in feet, are given below. Estimate the mean total stopping distance for automobiles traveling at 65 miles per hour in dry conditions using this sample and a 95% confidence interval. Assume that the total stopping distance for automobiles traveling at 65 miles per hour in dry conditions is normally distributed. Express the estimate both symbolically and verbally. The problem asks us to estimate. And statistically, we estimate things by constructing a confidence interval. Here, the estimate is for the mean total stopping distance of automobiles traveling at 65 miles per hour in dry conditions. The automobiles going 65 in dry conditions is just referring to one population. And the estimate is asking for the mean total stopping distance from this population. So we'll be doing our confidence interval to estimate this one population mean. Therefore, we need to follow these steps to guide us through the process of constructing a confidence interval. All confidence intervals start by specifying the confidence level. The customary confidence level is 95%. The problem does specifically state to use a 95% confidence interval. Even if it didn't specify us to use a 95% confidence interval, we still would use the customary 95 or 0.95 confidence level. Next, we can use the t-interval command on the TI-83 or TI-84 calculator to calculate our confidence interval. But before we use this command, we need to enter the data into a list in our calculator. To do this, we'd press Stat, Enter to get to the list editor. Then we could select any list we want to enter the data, such as List 1. Clear out the list of any old data to make room for the new data. Then we can enter the data values one at a time. Here, starting with the first data value, 345, and press Enter. Then 348, Enter. 342, Enter. And so on for all 25 different stopping distances, all the way to the last, 339 feet. Enter. Now that we have all the data entered into a list, we can then go to the t-interval command. We get to the t-interval command by pressing Stat, arrow the cursor over to the Test menu, arrow down till you find t-interval, press Enter to select. And on the t-interval page, it starts with a request for the input, or INPT for short. The choice is between data or the stats. Since we have the actual data inputted into a list in our calculator, we put the blinking cursor on data and press Enter to select. Then down arrow the cursor next to the list command. Since we entered our data in list 1, we would tell the calculator this by entering in L1. We could do this by pressing second and the number 1. Enter. Freq, short for frequency, is typically 1, so we wouldn't have to change it. That's because each one of these data values we entered came from one automobile traveling at 65 miles per hour in dry conditions, and we measured their stopping distance. Down arrow to the blinking cursor next to C-level. That's short for confidence level. And again, we're using the customary 95%. But in a decimal calculator, we enter 95% as the decimal 0.95. Then we arrow the cursor down to calculate. With it blinking on calculate, we press Enter, and the calculator calculates our confidence interval. We should take note that the sample size is 25. And 25 is not sufficiently large. In order for these confidence interval techniques to work, we need a sufficiently large sample. The rule of thumb in statistics is sample sizes over 30. But this sample was not over 30, it was 25. These techniques don't work well with the smaller sample sizes, unless we can make the following assumption. Here we assume the total stopping distance for automobiles traveling at 65 miles per hour in dry conditions is normally distributed. So if the population from which the sample is originally taken from is normally distributed, these confidence interval techniques work well whether we have a large sample or not. So now we're ready to express the estimate both symbolically and verbally. First, symbolically. Here we use the symbol mu for the population mean that we're estimating, surrounded by less than signs. Symbolically, this is how we show that this case, the population mean is in between the lower limit and the upper limit that makes up our confidence interval. Here, the calculator gives us the lower limit, L, as 343.98. We could leave the answer as 343.98, but if you want to round off the result, make sure you round off carrying at least one extra decimal place than the data has in order to reduce our round off error. Since our stopping distance were all measured to the nearest whole foot, we're going to estimate carrying to the nearest tenth of a foot. So in this case, in the 100th position, the 8, since it is over halfway, 5, we round the 9 up to 10, so we write down the 0, carry the 1, the 3 plus 1 gives us 4, and so our lower level estimate is 344.0. The upper estimate is 348.1. So symbolically, we give the result as mu is between the 344.0 and 348.1. Now we could express this estimate verbally using the words of the problem. The mean total stopping distance for automobiles traveling at 65 miles per hour in dry conditions is estimated to be between 344.0 feet and 348.1 feet with 95% confidence.